Hello everyone. Today we are going to discuss power systems, and in power systems we are going to discuss transmission. So coming to the transmission, uh, we need to discuss about the voltages that we operate in at various levels of transmission. So at transmission level we operate greater than or equal to 66 kV, which also include like 132 kV, 220 kV, 400 kV and 765 kV. At the distribution side we operate at 33 kV, 11 kV, and for industrial supply we use 6.6 kV, 3.3 kV, 1.1 kV and 400 volts. And coming to the household distribution, we get 230 volts single phase. Of course we get 3-phase supply, but as we are using single phase appliances, we do extract single phase from 3-phase, which is 230 volts. So throughout this is AC transmission, and throughout this the frequency is maintained at 50 hertz. And there is also another type of transmission, which is DC transmission, which is also called as HVDC. In this we are using high voltage DC. So the voltages generally be plus or minus 500 kV, plus or minus 800 kV. Since this is DC, the frequency is 0 hertz. The plus or minus sign is here due to the reason that in AC we don't have any plus or minus sign, but in DC we do have polarities. So we might take plus 500 kV or minus 500 kV from a HVDC supply. So we are using plus or minus 500 kV. And coming to the next one, that is the installed capacity in India. So the total installed capacity is 442 gigawatts. This number is very important for competitive exams. They do ask it, and even in the interviews too. So please remember this 442 gigawatts. And the data, everything regarding this can be found in the website of Central Electricity Authority. So you can find the reports even. And this out of this 442 gigawatts, so the percentage is distributed like this: from coal 47.3%, and from renewable energies like solar and wind etc. 32.7%, and from hydro, that is hydroelectric power plants, 10.6%, and from gas power plants the installed capacity is 5.4% of the total, and nuclear 1.8%, and diesel is 0.12%. This is the total distribution among the 442 gigawatts. So the highest even till today is coal. After that, renewable energies. The amount of coal has been reduced, and the renewable energy capacity has been increased during these days. You can observe that. And moreover, these all plants will be in remote locations, and the power will be transmitted from remote generating stations to the load centers, which is cities or rural areas. The reason for setting up the generating stations in remote area is that they might and they will cause pollution, so which people should not live beside these areas, so they are placed at remote locations. The transmission lines are classified as follows: short transmission lines, medium transmission lines, and long transmission lines. So these are basically classified as length of the line. Here the length is less than 80 kilometers. Here it should be 80 less than or equal to length less than or equal to 200 kilometers, and here the length is greater than 200 kilometers. So these three values are important: 80 to and 200. Which is less than 80 is short transmission line, which is greater than 200 is long transmission line, and between these two 80 and 200 kilometers is medium transmission line. And also not only this distance, it is also calculated as L into F, that is length into frequency. So here the length is 80 kilometers and the frequency is 50 hertz. So L and F value will be 80 into 50, which is 4000. Here LF will be in the range of 4000 to 10,000. Here the LF is greater than 10,000. So if LF is less than 4000 and if the LS is between 4000 to 10,000, it is called medium. If the LF is greater than 10,000, it is called long. So not only based on the distance, it is also classified based on the product of length into frequency. So this is also important, please remember this. So we'll do one example on this. Find the type of line. 300 hertz, 50 hertz, 600 hertz, and given length is 20 kilometers. This is the physical length and this is the frequencies of operation. So please do this. So we need to find, since frequency and L is given, we need to find LF. So here the LF is 20 into 300, which is equal to 6000. This is between 4000 and 10,000, so this is medium transmission line. And coming to this 20 into 50, which is 1000, this is short transmission line. And coming to this 20 into 600, this is 12,000, which is long transmission line. So I hope you understand this topic based on how to classify the lines based on L into F product. So the next topic is the conductor. The conductor which is used in transmission lines is ACSR conductor, which is aluminum conductor steel reinforced, and the middle portion will be made of steel and the outer portion will be made of aluminum conductors. So there is even a formula to find the number of conductors for each layer. Suppose in this there is the first layer is the center one, the second layer is this red one, and the third layer will be of aluminum, fourth layer will be also aluminum. So we will find the number of conductors in each layer in one formula, that is number of strands or conductors is equal to 3x square minus 3x plus 1. Here x stands for layer number. Suppose the layer number is first layer, x is equal to 1. The number of conductors in that layer is, substitute 1, 3 into 1 minus 3 into 1, this is 0 plus 1, so 1. There is only one conductor. For x is equal to 2, that is in the second layer, substitute 2, n is equal to 3 into 4 minus 3 into 2 plus 1, which is 12 minus 6 plus 1, which is 7. There are 7 conductors in the second layer, and so on. If you take x equal to 3, which is the aluminum conductor layer, so n will be 3 into 9 minus 9 plus 1, which is 18 plus 1, which is 19. So 19 conductors will be in the third layer, and so on. And there is also one more formula regarding this, which is if we take the diameter of each conductor as d and the total diameter of the conductor capital D. So if we know small d and if we want to find capital D, the formula is capital D is equal to diameter of whole conductor is equal to 2x minus 1 into d. Here x is number of layers. Suppose in this number of layers is 1 2 3 4, so 2 into 4 minus 1 into, let us think the diameter of each wire as 5 mm, so let it be 5 mm. So the total will be 7 into 5, which is 35 mm. So for a 4 layer conductor of each diameter of 5 mm, the conductor total diameter will be 35 mm.